In this video, we're going to talk about normalization, which is a very important concept to understand within computer graphics. And it significantly simplifies a lot of the mathematics that you want to be able to do. The basics of normalization is that when you're normalizing values, you have the value that you're currently working with, a min and a max, and you want to translate these values between a value which is 0 and 1. So essentially, a normalized value takes any range that you have and converts it to a value between 0 and 1. The reason why I want to do this is that it actually can work like a percentage of a thing. So let's consider the values that we have at the top here. I have data values that start with 0, which is the minimum value, and the maximum value of the data is 10. And I want to translate those values to color values in RGB. So the RGB values is 0, which is black, and 255, which is white. So the theory behind this is as following. If I have a range of values between 0 and 10, which is my data values, and I pass in the value 0 to be normalized. 0 represents the minimum value, right? So that should be 0. And if I pass in a 10, which is equal to my maximum value, I should get back a 1. Therefore, because 5 is in the middle of my value range of 0 and 10, when I normalize it, I should get back 0.5. So when I run this, you can see that's exactly what I get. When I send in the minimum value, I get 0. When I send in the maximum value, I get 1. And when I send in a value that's in between them, I get a fraction between 0 and 1. So let's look at how we actually put this into practice. Here I've got an input range. You can also see it here at the top. And when I sort of slide this input range, you'll see that the color changes on the background, right? So we put in a minimum value for the color range and a maximum value for the color range, and we set the current value on the color range. So when I move this thing around, I'm going to get either a 0 or a 10 or something in between. So I've got a change event listening to this, and I've broken the math down into very simple steps so it's easy to follow. The first value that I have is my data value, the value between 0 and 10. Now keep in mind, this doesn't have to be 0 and 10, it can be minus 500 and 1,020,000. It doesn't care. As long as you pass those values into the normalized function as well. So step 1, let's get the data value that I'm working with. Step 2, let's normalize that value, passing in the value that I'm working with, the minimum value and the maximum value, and the normalized value will be a value between 0 and 1. And then, because we know that we are working on 255, which is our color value, we can times 255 by our normalized value. So what happens now is if I say 255 times a fraction, I'm going to get a fraction back. The problem is that RGBA doesn't work with fractions. It has to be a value between 0 and 255 without any floating points. So to take out the floating points, I'm just using a truncate where we're saying whatever the floating point is, throw the remainder away, just give me the decimal value. And then I'm setting the background equal to the R, the G, and the B using the same value, which is going to give me my grayscale. Having said that, now when I change this value, you can see that when my value approaches 0, it turns black. Somewhere in the middle I get a nice light gray, and towards the max value I get white. So let's go and change the values up of the data a little bit, just to prove that it doesn't actually matter whether or not it's simple values like these. Okay, I've changed the values of our input, so the minimum value is now -10 and our maximum value is 120. I've also changed the min value that we pass on to the normalize as -10 and the maximum value to 120. And so when I move the slider around now, you can see the color still works as expected. Our maximum value turns white, our minimum value turns black. Normalization. Definite Swiss Army knife you need in your toolbox.